Okay, so let's move to our today's lesson is called lenses. Okay, so we are today discussing about what is lens. Okay, and here in the first slide, we can find there are two kinds of lenses right here, right? And on the left, we can find this is a convex lenses. So it's like you can find in the middle is very have a big lines, and maybe you can find in the two side you will find the lenses has a very sharp side, right? So we call this a convex lenses. Okay. And another is concave lenses, okay? And in IGCSE, we always discussing about convex lenses, okay? And here are three properties for convex lenses you have to remind this, okay? So for the first property is that when here is a parallel line just passing through the the lenses, and it will refracted and then passing through the focus, okay? So maybe here you have a question. So, teacher Mai Lin, what is focus? Okay, so I remember when I was a small child, I at that time the glasses or on your nose is just made by glass. Okay, and you can use it to make fire. Okay, when there's a very big sunshine, you can use it. And at that time, remember I was a very small child. I used this and to investigate how ants move their houses. Okay, so we can find that the rays just refracted like this way. Okay, so we can set that here's a focus, and we can let all the parallel lines from the sun, because sun is very far away from us. So we can consider the rays of it. It's just like parallel line. Okay, so here every sunshine just refracted to the focus, and they can burn, and they can make a very high temperature at these places. Okay, so this is for the first property that parallel lines or parallel rays will pass through the focus. Okay, this is for first property you have to remember here. Okay, and secondly, we can say that if there is a ray just passing through the center like this way, okay, and we can set here because it passes through the center, so it just doesn't has any reflected. Okay, so we can set the second property is if the ray passes through the center, just keep on its path. Okay, this is for second property. And the third property is that if a ray is from the focus like this way, and if there's a focus, remember here that there are two focus for the lens. One is on the left and another is on the right. Okay, so you can set here that the ray just passes through the focus and then reflected like this way, and it forms a parallel rays. Okay, so here is for the focus. Okay, and we can set it right here, and the rays just passes through it and then refracted and to form a parallel rays. Okay, so here is for the focus. Okay, so just remember these three principles. So let's move into some real question for the focus. Okay, and here I have already drawn a graph like here, and you can find on the left there is a small arrow. In the model time, we use a small arrow to represent for an object. Okay, and you can find after the lenses, you can find maybe if we are choosing the top of uh, the arrow as a point, and we can say the point can has many rays, like a point can like a bubble, like it can bulb can has many rays outside, right? Like this way. So we can say that it's because of point, so we can uh produce many rays outside. Okay, so maybe first pass is the parallel rays, and then find it just through or pass through the focus, right? And we can draw this line. Okay. And if we just draw a line passing through the focus, and after the lenses, we can say it's refracted, okay, and becomes a parallelized, okay. So we can say that two rays just intercept at the same point, okay, or they have there is an intercept, right? And we call the intercept as an image for the object, because when you draw many kinds of like lines, or maybe for the third line passes through the center, it also passes through this point, okay, like this way, okay. So we can set all the lines just like converge in this point. So we can set this is an image for this point, okay. And maybe you can also draw other points on the arrow, like this point, and it's reflected after the lenses by using the three properties we said before, like parallel. After the lenses, it passes through the focus. Rays from focus passes through and then becomes a parallel lines. And if a rays passes through the center of the lenses, it doesn't have any difference on its path, right? So you can draw many image or many dots for each image, okay? So then you can find there just form a new arrow like here, okay? So we can call this as an image, okay? So here is for this formula. And here we can already like draw two symbols right here. One is called U, another is called V, okay? So U means the distance from the object to the lenses or center of lenses, okay? And V represent for the image distance to the center of the lenses, okay? And here, this formula don't need to remember, but in our test, sometimes in P6, we will have this proof for this formula, okay? We have investigation that 1 over U plus 1 over V equals to 1 over F, okay? And you can find here that the F means the distance from the focus to the center. Okay, so this formula just like obeys the rule. Okay, so maybe you can sorry, you don't need to remember this, but you can use that in drawing the graph and to determine whether you're right or not. Okay. So for the second here, you can find there's an arrow upwards, right? And you can find the arrow has two rays. Like first, it can shoot a parallel rays after or just through the a point of this, right? And then it can have a parallel rays just pass through the focus like this way, okay? And maybe another rays just can from its like the top of the arrow and then just pass through the lens's center, okay, like this way, okay? So you can find that maybe here the two rays are passing through, but their distance are increasing and increasing, right? So maybe we cannot find the intercept at this direction. So maybe rays can be upward propagation, but they can also be backward propagation. So like here, if you're just using these rays to prolong it, okay, it's not like just see in the mirror like this way, okay? We can regard it that it is a virtual image, right? So you should for the virtual ray as these rays, as these blue rays, and then prolong them and they intercept at this point, okay? So you find the intercept, but please remember that we are prolong in a very different direction. So here it is a virtual point. Okay. So each point on the arrow just then reflected back and becomes a virtual point. Okay. So every virtual point forms a virtual image. Okay. This is how the virtual image comes from. Okay. So you can find at these places, we call this circumstance or this like U smaller than F. That means the distance from the object to the lenses is smaller than one focus length. Okay. So you can find this image has three properties. First is enlarged, okay. And secondly is just upright with the like maybe we can say as a object, okay. And secondly, thirdly is virtual image, okay. There are the three properties for it, okay. And maybe for another you can see here is like the object is just on the focus, okay? So we can say that U equals to F. And in this way, you can find that if you're drawing two lines and one is parallel rays and then pass through the focus, and another ray just passes through the center, you can find they're always parallel rays, okay? Because these two triangle, like here, this triangle just the same as this triangle, okay? Because they have the same angle, like here theta 1 equals to theta 2, so you can set theta 1 equals to theta 2, so the two rays are parallel with each other, okay? There's for these two triangles like this, two rays like this way, okay? So maybe we can find if you also prolong the rays backwards, they also a parallel ray, so it cannot have an intercept, right? So we can say right here, there's no image, okay? But also you can use the formula to prove this because 1 over u plus 1 over v means 1 over the distance from the object to the mirror plus 1 over distance of the image to the mirror equals to 1 over the focus length, right? So here we can find if u equals to f, so that means this equals to this. So we can delete them together and after that 1 over v equals to 0, okay? So this is for this formula, 1 over v equals to 0. Okay, so you can find there is no solution for V or there's no root for V, right? So we said that V doesn't exist or this function doesn't have any solution, okay? So that means we doesn't have any image, okay? And you can find in the third situation, maybe the object or maybe the U, the distance from the object to the center of the lenses, like here, you can draw the three lines. Like first line is a parallel line and passes through the focus, and second line is passes through the center, and third line is passes through the focus, and then formed at this part. Okay, so you can find this is the real rays that they converge together and they becomes a real point like this way. Okay, so this is a real object or real image. Okay, so we can say here, blue rays is a real image or a real arrow. Okay, so here we can discuss for the three properties. First is enlarged, right? Because it's larger than the object. Okay, and then it is inverse. Okay, because the direction is very different. Or you can also say inverted. Okay, and it is upside down. And thirdly, it is a real image. Okay, it is just formed by the real rays. But like you maybe you have a question. So why they're passing through the lenses and real rays? Because they're just from this way. So if you're drawing backwards like this way, so you're just looking in the mirror, like your face is looking in the mirror. The face in the mirror is virtual, right? So we can also say that if you like prolong the rays in another direction, it is virtual. Okay, so here is a real image. Okay, and maybe here you can draw like u equals to 2f, and you can find that you can draw in the parallel rays and then pass it through the focus, and draw the rays passing through the center, and draw in the rays passing through the focus, and become the parallel rays. Okay, please remember parallel to axis. Okay, the center is the axis. Okay, and you can find the image also lies on 2f places. Okay, that means you can find there's the same angle and same size and they're in the same direction. Okay, so you can see here it is inverted and the same size and it is a real image. Okay, and if you adjust your distance from the object at maybe over than 2f, you can find maybe first draw a parallel rays and then passes through the focus, and another rays passes through the center, and you can find it's inverted, and maybe it's for like a small size, and it is like a real image. Okay, so this is for u bigger than 2f. Okay, so in the real test, you don't need to remember all of this. You just need to master the principle of drawing these lines. Okay. So here is for drawing the diagrams like right here, okay. And you'll find this is an object. An object can like have many rays outside, and maybe first it can have like a parallel rays right here, and then after the lenses it deflect and passes through the focus, right? And you can find another rays can pass through the center and just doesn't change its direction, okay? And they have a focus or they have converging places, okay? And we can see right here, the image is a real image and inverted, and it is bigger than the real object, okay? So we can see this is properties for the image, okay? And here is the exercise for you to master whether if you're understanding about how to draw in the image, okay? Try to solve this problem, please. Okay, so let's do it together. Okay, so maybe for this question, you can draw three lines or three rays if you like, right? First, you can draw a parallel rays and it must pass through the focus, right? Like this way. And for second rays, you can say it passes through the center and it's just moving forward, right? Maybe the third rays, you can say it's passing through the focus, but maybe here the focus right here, right? Okay, so maybe you can just draw in the two rays, right? You can find if you're just drawing forward and you can find the distance between the two rays is bigger and bigger. So that means it doesn't have intercept at these places, right? So the intercept must be at this place, right? So we can just prolong the rays in another direction, like this way and this way, okay? So you can find them, they're just, sorry. Okay, so it's just here we have a intercept, right? So then we can draw, because the red rays, for this red rays is a real rays, but for this real rays is a virtual rays, right? You can just like draw it like this way. Okay, so it's a virtual ray. So that means the object must be, oh sorry, the image must be a virtual, right? And it's upright and it is enlarged. Okay, so we can see here it's on the same side of the lens as the object, right? Because they're all on the or both on the left side of the object, or sorry, on the of the lenses, right? They're on the same side of the lenses, right? And it's larger than the object. Okay, so we finally choose the C as our final answer. Okay, this is for our question. Okay, so this is for today's lesson. Okay, if you have any question, please just give your comment and maybe you can give your any answer to me and maybe you can add me contact and give your answer. Okay, so see you next day. Bye.